Here is a sketch of line L. The point P is at -6, 0, and the point Q is at 0, 3, and both the points lie on the line L. The point R is such that PQR, so going from point P up to R, is a straight line, and going from P to Q, and then going from Q to R, the distance is of the ratio 2 to 3. And using this information, we want to find out the coordinates of R. So firstly, I'm going to have a look at the x coordinates. So we're going to go from -6 for P to 0 for Q, and then from 0 on Q to something we're not sure about yet for R. And the ratio here is 2 to 3. So we're going from -6 to 0. So if I do 0 minus -6, it's going to equal 6. So we're in the ratio 2 to 3. We can see here for the x coordinate, P to Q is going to be 6. So we're in the ratio 6 to something. To get from 2 to 6, what do we do? Well, we multiply by 3. So if we do that to the other side here, we're going to get 9. So the distance from Q to R in the x direction is 9. Now let's do the exact same for the y coordinates. So the distance between P and Q, we're going from on P, it's on the x-axis, so it's 0. And at Q, it's got a y value of 3. So we're going to have 3 minus 0, which equals 3. And again, we've got our ratio of 2 to 3. Now we know for P to Q, it's 3. So how do we get from 2 to 3? We're going to multiply by 3 over 2. So if we do the same to the other side as well, if we multiply by 3 over 2, we get 9 over 2. We're almost there. So look at R. We want to know its position on the x-axis and its position on the y-axis. Well, we know that going from Q to R, like this, is a distance of 9. Well, that's the same as going from the origin to R. So the position of R on the x-axis is 9. So we can put in here an x value of 9. Now we know here, going from Q up to R, that's a value of 9 over 2. However, the y coordinate of R isn't 9 over 2. So we can see here, we've still got this bit from the origin. So this distance here is 3. So the distance here of R to the origin in the y direction is going to be 9 over 2 plus 3. So 15 over 2. And then that's our final answer. We can put that as the y coordinate of R. So we get 1 mark for all of this working out here, and a second mark if we get the x coordinate and the y coordinate correct. Now part B says we need to find an equation of the line that is perpendicular to L and passes through Q. Now the first thing I'm going to do is I'm going to find an equation for the line L. So to do that, we need 2 points that go through the line. So I've got Q and P. And let's work out the gradient. So from these 2 points, the gradient, so M, and we work that out by doing the change in y divided by the change in x. So if we do the change in y, so I'm going to do the y of Q minus the y of P, so 3 minus 0, over the change in x, and we need to keep it the same way around. So I'm going to do the x of Q minus the x of P, so 0 minus 6, that's going to give us 3 over 6. So this is the gradient of the line L. So now we want to find the equation of the line that is perpendicular to L. So to get the gradient of the perpendicular line, we need to take the negative reciprocal of the gradient. So doing that, we flip the numerator and denominator. So we're going to get 6 over 3, and we make it negative. So this here is the gradient of the line perpendicular to L. So now let's work out the equation of the whole line itself. So the equation of a line is y minus y1 equals m multiplied by x minus x1. And we're told that our line should pass through the point Q. Well, we know what the coordinates of Q are. So we've got all we need. So we've got y minus y1, so minus the y value of Q, which is 3, equals m. So we work that out as minus 6 over 3, multiplied by x, minus x1, so the x value of Q, minus 0. And let's tidy that up. So we're going to have y minus 3 equals, well, minus 6 divided by 3 is minus 2. And x minus 0 is just x, so minus 2x. And tidy that up again, we're going to add 3 to both sides. We're going to get y is minus 2x plus 3. And that is the final answer. The equation is y equals minus 2x plus 3. So we get our first mark for finding the gradient of L. Then we get another mark for finding the gradient of the perpendicular line, so taking the negative reciprocal. Then we get a third and final mark for the correct equation of a line.